assignments. Then we have Nabil Khan. Nabil Khan, you have not submitted any assignment. When you will complete it? Nabil Khan, when you will submit the rest? I will submit my next class. Okay. Okay, and Noma, very good. You have completed 9 assignments. In last week, from the slide, I have given some questions of continuity. Anyone has completed that? Noma, Nabil, Saf, Zephyr, Atif.
I was absent, sir.
You were absent. Okay, then please check the recorded lectures. Okay,
Yes,
Atif,
sir.
Atif, Zephyr, Nabil, and Noma completed any question from the slide? No. Please complete this week only. Okay, and Noma, how was the exam?
Sir, it was fine.
Fine. Okay. Okay, then we will continue our topic.
Excuse me, sir.
Yes, sir.
Yes, I have submitted you from assignment 1 to 8.
Sir, you have submitted up to 8. Okay, let me again share the sheet. Okay, sir. So, second and third also, sir.
Yes, sir.
Okay, then I need to check this again. Okay. And tomorrow you have a test of differentiation. Okay. So we have already almost completed the continuity, and I have given some questions from the continuity. Okay, and these are very good questions. So please complete that. And if anyone have a doubt in these questions, then please let me know. Okay, I hope you can do the questions on your own. Now we are going to start the differentiability. Okay, first of all, we will see the formula of differentiability. Okay, and after that, we will try to check that what is differentiability from the graph point of view. Okay. Okay, so yeah. Let fx be a real valued function. Let fx be a real valued function defined on this interval, defined on open interval AB, and there is a number c which belongs to AB. Okay, you have a function fx which is defined on this interval. It is defined in this interval, and you have a value c which belongs to this interval. Now fx is said to be differentiable or derivable. Fx is said to be differentiable or derivable at x is equal to c if this limit exists. Limit x tends to c fx minus fc by x minus c exists. Okay. How we will get this limit? That we will do later on. Okay. In today's class only we will do this. But first of all, we will try to solve some questions. So what when fx is said to be differentiable when this limit exists. Now anyone can tell me when a limit will exist, when we will say that a limit will exist. This is nothing, this is a limit.
When
Yes,
LHL equals to RHL.
very good. Okay, so when LHL and RHL are equal, then we will say that the limit exists. Now here we are talking about the differentiable, so here we will not say LHL, we will say LHD. What is LHD? It is left hand derivative. Left hand derivative. Okay, so this limit, first thing, this limit is called the derivative of fx at x is equal to c, and it is denoted by this sign. Okay, first thing, this limit is called the derivative of function at x is equal to c, and it is denoted by this sign. Now the next thing is this c minus. you all already know that minus represent the left side, left hand. Okay. Here we are saying in place of LHL, LHD, because we are talking about the derivative. So this x tends to c minus is called the LHD of fx at x is equal to c. Okay, x tends to c minus fx minus fc by x minus c is called the LHD of fx at x is equal to c. Here we have checked that the function is said to be differentiable if this limit exists. Now, if x tends to c minus is called the LHD. Similarly, x tends to c plus is called the RHD. RHD of the function at x is equal to c. F is differentiable at x is equal to c if LHD is equal to RHD. This you already know. Okay. So when we will say that a function is differentiable at any point, when this limit exists. When this limit will exist, when the left hand derivative is equal to right hand derivative. So in a question, if you need to check that the function is differentiable or not, then you need to find the LHD left hand derivative. Okay, this is left hand derivative, left hand derivative, and we will check RHD. RHD is what? Right hand derivative. So when LHD and RHD are equal, then we will say that the function is differentiable. Okay, so all of you please note down this. Let me know if anyone have a doubt in this. Otherwise, we will start the question. Okay, please note this and raise your hands once it is done. Everyone, please raise your hands once it is done. Okay, Joseph. Okay, Nabil.
Sir, sir, in
Yes.
right-hand derivative, would we need to add f of x and f of c?
The question is in left hand derivative, what we need to add.
Right-hand derivative.
Okay, in right hand derivative, what we need to add.
Yes, sir.
Okay, so when we were doing the limit, then in RHL, we always put C plus H while solving the question. Similarly for LHD, we will put C minus H. Okay.
Okay, sir.
So Nabil has done, Noma has done, and Atif, is it done? Shall we start next?
1 minute, sir.
Okay, 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 okay. Okay, Atif. Good. Is it done, sir?
Yes, sir, done.
Okay, okay, great. Now we will start the question. If anyone is left, then please let me know. Okay. We have this modulus question. We need to show that fx is equal to mod x is not differentiable at x is equal to 0. So what will be the first step? Anyone can tell me in modulus question, what is our first step?
Define both positive and negative values.
Very, very good. First of all, we will define the modulus. So anyone can tell me how we define this modulus? How can we define this modulus? No one?
X when x is greater than or equal to 0 and minus x when x is less than 0.
Very good. Very good. So whenever you're getting any modulus question, then always please define it. And if anyone have a doubt how to do this, please let me know because there's a very important concept. The same concept we will use in integration also. Okay. So always please define it. So we will define it this way. Now we need to show that this is not differentiable. So first of all, we will find the LHD. LHD at x is equal to 0. Okay. So how we will write it? Limit x tends to 0 minus fx minus fc by x minus c. Okay, limit x tends to 0 minus fx minus fc by x minus c. Now, the same thing which we have done earlier, to put x is equal to 0 minus h. This is not a new thing for you. You know, whenever you have to find the left hand limit, then always put 0 minus h. You can write here when x tends to 0 minus h tends to 0. Okay, so here you will get what? Limit h tends to 0. In place of this fx, we will write 0 minus h minus fc by 0 minus h minus 0. Okay, I've written here c. So we will write 0. Okay. Okay. Now, next question is from Seth. Seth, can you tell me for left-hand derivative, which function we will use?
The first one.
First one for left-hand derivative. No, that's not correct. Please check yourself. 0 minus means we are approaching this 0 from the left side. If you are approaching from left side, then that means the value is slightly less than 0. Okay, so
And
here,
second.
second one. So here we will write what? Minus x. So that means minus, and in place of x, we will put what? Minus h. What is here? We have a 0. What is f 0? This will become 0 by minus h minus 0. Limit h tends to 0. Minus minus plus h by minus h. Cancel out this. You will get limit h tends to 0. And this is minus 1. And this will give you minus 1. Is it clear to all of you? Please raise your hands if it is clear. No,
So how did you get F0?
F0. Okay, okay. It is better if I will write one more step. Just give me. First of all, we will write the function x0 minus. Okay, in place of this, we will write minus x minus f0 by here we have written x minus 0. Okay, everyone know why we have written minus x? Because this is left hand derivative. That's why we are using the second function. Now put x is equal to 0 minus h, x tends to 0 minus h tends to 0. So here we will get limit h tends to 0. Now in place of minus x, put this value, so 0 minus h. Okay, so f we need to find. Okay, sorry. Now, Seth, we have this fx is equal to minus x. Okay, if we need f0, then what will be the value? Seth, what will be the
Plus
value?
X.
No, in place of x, you need to put 0. Okay,
Yes.
0 by, in place of x, we will write minus h minus 0. So here we will get what? Limit h tends to 0. This will become plus h by this is minus h. So limit h tends to 0. So this will give you minus 1 and the final answer is minus 1. Okay. So I hope, Saf, this is clear to you. So all of you, please note down this. And in the same way, please try to find RHD and tell me what the RHD you are getting here. Okay. And if anyone have a doubt, then please let me know. Okay. Noma, so what we have done, we need to find LHD here. LHD at x is equal to 0. So if you will check the formula, you have this formula for LHD. Please check the previous slide. You have this formula, limit x tends to 0 minus fx minus f0 by x minus 0. Okay, and here we have defined the mod. Now for the LHD, we will use the second function. Why second? Because this is less than 0. So in place of fx, we will use minus x minus f0 as per the formula by x minus, we have here 0. Now, the same thing put in place of x0 minus h. Okay, so when x tends to 0 minus h tends to 0. So in place of this x, just write 0 minus h minus 0 by the same thing. H tends to 0. Now here you will get h positive by minus h. Here minus 1 and final answer is minus 1. Okay. So all of you please note down this. In the same way, calculate the RHD and let me know if you have any doubt in it.
Sir, in the denominator, why you put C as 0, sir? Of C.
The denominator, this x minus 0.
Yes, sir.
Please check the formula. Okay, fx minus fc by x minus c. Okay, Nabil?
Yes, sir.
And I will explain you by the graph how we are getting this one. Okay.
Sir, RHL is 1, sir.
Yes, that's correct. Very good, Nabil. RHD. Okay, RHD is 1. So please write LHD at x is equal to 0 is not equal to RHD at x is equal to 0. Hence, the function is not differentiable at x is equal to 0. Very good. All of you, please calculate the RHD and tell me the answer. Or if anyone is facing issue here, then please tell me.
Sir, how is the value of C0?
How the value is C0? Because in the question it is given at x is equal to 0. Okay. We will check the previous slide. Here what we are seeing that C is any number. We need when we will say that the function is differentiable at x is equal to C when this limit exists. Okay. So in this question, we need to check that the function is differentiable at x is equal to C or not. So here it is given that x is equal to 0.
Okay, sir.
Okay. Raise your hand, please, whoever has calculated RHT. Okay, Nabil. Good. Okay, Saf. Very good. Saf, you're also getting RHT 1.
Yes.
Very good. So at last, please write LHD at x is equal to 0 is not equal to RHD at x is equal to 0. So fx is not differentiable at x is equal to 0. Noma, very good. Josefa, Atif, Nabil Khan, please confirm. Okay, Atif, very good. Okay, Nabil, very good. Josefa, is it done? Josefa, is it done? Okay, great. So I hope everyone has completed this. Now we will start the next question. Next question is, show that this function is not differentiable at x is equal to 2. Okay, so the same formula, please apply the formula here and let me know that this function is differentiable or not at x is equal to 2. Okay. Okay, Atif, so you are getting very good. This is correct. So please write Atif, RHD is not equal to RHD at x is equal to 2. Hence, fx is not differentiable at x is equal to 2. Anyone else has completed this? Please let me know if you have any doubt here. No, it is not correct. Okay, LHD is fine, it is 1. RHD is not correct. Nabil Ahmed, Zafar, Saf, Nabil Khan, is it done? Okay, Zafar. Zafar, what is the answer? Zafar, what is the answer?
Sir, LHL is equal to 1, RHL is equal to 4.
No, RHD, okay, not LHL. Yeah, RHD is 2.
Okay, sir.
Okay, no, Zafar, it is not correct. Please check here. So first of all, we will calculate LHD. LHD at x is equal to 2. So this will give you what? Limit x tends to 2 minus fx minus f2 by x minus 2. Now, Josefa, which function we will choose for our LHD? Yeah, the first one. Good. Now f2. Okay, we have this function, this one. Put the value 2 here, so you will get 2 minus 1 is 1 by x minus 2 means just remain as it is, x minus 2. Now put x is equal to 2 minus h. Right here, when x tends to 2 minus h tends to 0. So here you will get what? Limit h tends to 0, 2 minus h minus 1. Okay, minus 1 by 2 minus h minus 2. So here you will get limit h tends to 0. 2 minus h minus 1 is what? 1 minus h minus 1 by minus h. Cancel out this one. So you will get limit h tends to 0 minus h by minus h. Cancel out this. You will get limit h tends to 0. This is 1. Answer is 1. Okay. So I hope this is clear to everyone. Now we will calculate RHT. Because most of you have the mistake in RHT. RHT at x is equal to 2. So limit x tends to 2 plus fx minus fc means f2 x minus 2. This is equal to limit x tends to 2 plus. For RHT, we will use the second function 2x minus 3. Okay, everyone know the reason. So 2x minus 3 minus f2 by x minus 2. Put x is equal to 2 plus h. Okay. So when x approaches to 2 plus, h approaches to 0. So here we have limit h tends to 0. 2x minus 3 means 2 into 2 plus h minus 3 minus f2. f2 means we have this function 2x minus 3. Put the value here 4 minus 3 by x means 2 plus h minus 2. So here we have limit h tends to 0. Open the bracket 4 plus 2h minus 3 minus 1 by h. So here 4 minus 3 is 1. So you will get limit h tends to 0. 2h plus 1 minus 1 by h. So limit h tends to 0. 2h by h. Okay. Two h by h will cancel out. So limit h tends to 0. 2. So the final answer is 2. Okay. So you can say LHT at x is equal to 2 is not equal to RHT at x is equal to 2. Hence, fx is not differentiable. Fx is not differentiable. It's not differentiable at x is equal to 2. X is equal to 2. Okay. So I hope this is clear to everyone. Please note down this, raise your hands, then we will check the next question. Okay, Noma. So I'm just changing the slide. Okay, Nabil, very good. Noma, please let. Okay, okay. Shall we start next? All of you have done this. Is there anyone who is left? I guess no. So we are going to start next. If anyone is left, then please let me know. Okay. Now, this question is homework. Okay. This is homework. This is a very simple question. You need to show that this is differentiable at x is equal to 1. So you know the method. Okay. And the LHD or RHD will be what? That will be derivative of 1, which will be represented like this. So all of you, please raise this, note down this question. Raise your hands so that we can start the next. Okay. Please note down this. Okay, Nabil, very good. Atif, Huzafa, Saf, and Nabil, Noma, please raise. Okay, Noma, good. All of you, please raise your hands if it is done. Good, Saf. Atif, Huzafa, Nabil Khan. Atif, Huzafa, and Nabil Khan. Is it done? Okay, you have already found out the answer, Huzafa. Good. That is correct. Okay, great. So I will give you the answer here. Answer is 2. Okay, it is differentiable and this value. I will write this. This is equal to 2. Okay, you can do this question on your own. Now, next, this question is also a homework. Okay, because the same type of question we have already discussed in continuous function. So you need to define this mod. Okay, and when once it will be done, once you will define this, then you need to check that the function is differentiable at x is equal to -1 and 1. Okay. So please note down this and again raise your hands when it is done. It's a very good question, came in CBSE 2015. Okay. Please do the homework. Okay. Please raise your hands once you will note down this. Okay, Nabil, very good. Okay, Atif. Okay, Noma. Huzaifa, Saf, and Nabil Khan, please confirm. Okay, Huzaifa, Saf, and Nabil Khan, please confirm. Okay, Nabil, Saf, please confirm if it is done. Okay, great. Now next one. Again, this question came in CBSE 2020. So this is also homework. You need to define this mod. Okay, I will give you the hint. You have to do this in the homework. Here we have x into mod x. Mod x, you already know what is mod x. X when x is greater than or equal to 0 and minus x when x is less than 0. So here you have x into mod x. So what will happen? When x is greater than or equal to 0, this becomes x into x, which is x squared. When it is less than 0, we have x into minus x, which is equal to minus x. Okay. So please note down this question. This also you need to do in home. Everyone, please raise your hands once it is done. Okay, Atif. Good. Oh, okay, Saf. Huzaifa, Noma, Nabil Khan, please confirm once it is done. Okay, Nabil, very good. Okay, Noma, good. Josefa, is it done? Okay, Josefa, very good. Our next one. Okay. Now, we will try to understand that what is mean by left-hand derivative, what is mean by right-hand derivative, and why the function is differentiable when these two are equal. Okay. So we will draw a graph here. Suppose we have this curve. Okay. There is a point B here. And this is X. And this is your fx. Let this be a point C. Okay, so you know that in this XY coordinate system, first we will write X coordinate, which is C. Anyone can tell me the Y coordinate for this? This is a function of X. Okay. Or I will write Y here. I will write Y here. This is a function. Anyone can tell me what is the Y coordinate here? The X coordinate is C. What is the Y coordinate?
X.
No, not X. Please check here. Fx. Okay, so if you will put in place of X this C, you will get FC. So the second Y coordinate is FC. Okay, always remember X coordinate we will write here, and for the Y coordinate we will find FC. Now this is a point B. Suppose I am taking a point A here. Okay, and this one I'm taking this point as C plus H. Now anyone can tell me what is the Y coordinate here?
F of C plus H.
Very good. Okay, same thing, FC plus H. Okay, now we will find the slope of AB. This is a line, we will find the slope of AB. Anyone remember the formula which you have done in class 11, slope of a line? If you have two coordinate x1 comma y1 and x2 comma y2, anyone can tell me the slope of this? Suppose there's a point A,
X2 minus X1 by Y2 minus Y1.
y2 minus y1 by x2 minus x1. Okay, this is a formula. So slope of AB, this is equal to what? We will take this point as a y2. So fc plus h minus fc by c plus h minus c. Okay, so I hope up to this point everything is clear. What we have done, we have taken a point A, we have taken c plus h, and we have find out the slope of AB. Now we need to find the slope of a line at point. Now suppose this is AB. This is AB. Okay, this is the line AB. We have to find the slope of AB. So what we will do, we have applied this formula and we get this fc plus h minus fc by c plus h minus c. Now, if we need this point A very, very, very close to B, then what we will do? If you will decrease this value of h, then definitely this point will come very, very close to B. So what we are doing here, we are writing limit x, sorry, limit, yes, x, h tends to 0 f c plus h minus f c by c plus h minus c. Okay, so what we have done, we have taken the limit h tends to 0. Okay, because we need this point A very close to B. So what we will get, so now suppose this point is very, very close to B. So we can say that this is nothing. This is nothing. This is slope of tangent. Slope of tangent at point B. Okay, so this limit h tends to 0 f c plus h minus f c by c plus h minus c will give you slope of tangent at point B. And this is also the RHT. RHT at x is equal to c. Okay, now we will take a point, suppose D here. And this point is what? This we will take c minus h. And so this point will become c plus h. What will happen? We will get a line BD. Now slope of BD is equal to f. Again, the same thing. Why I've written c plus h here. So here we have c minus h. Here we have fc minus h. So slope of BD is equal to fc minus h minus fc by c minus h minus c. Okay, we are finding the slope of this line BD. If we will take the limit h tends to 0, so we'll get fc minus h minus fc by c minus h minus c. And we can say this is slope of tangent at point B. And this is nothing. It is LHD at x is equal to c. So what we are doing, if we are finding the LHD and RHD, then we are getting a slope at point B. So slope should be same. So when we are saying that LHD is equal to RHD, if then slope, okay. If LHD is equal to RHD, then fx is differentiable at x is equal to c. Okay. Here. Now please check here. So what happened? We need the slope of tangent at point B. So we have find out the slope of tangent at point B from the right side and the left side. Slope should be equal. Slope should be equal. That's why if LHD is equal to RHD, then we can say that slope at point B is equal. And that's why we will say that the function is differentiable at point C. Okay. Is it clear to everyone? So if the slope is equal, then we will say that this function is differentiable at point B, and we can also write LHD is equal to RHD. If LHD is equal to RHD, then there exists a unique tangent at point B. Okay, so that means if LHD is equal to RHD, then there exists a unique tangent at this point. There will be only a single tangent at this point. So if at any point you will get more than one tangent, then your function is not differentiable. So please remember some cases when we will say that any point the function is differentiable when there exists a unique tangent. If at that point there exists more than one tangent, then we will say that the function is not differentiable. What the derivative give you? Will give you the slope of tangent at that point. If you, for example, in the previous questions, here we are checking the differentiability at x is equal to 0. So we are checking that at that point, a unique tangent exists or not. Okay. Is this clear to all of you? Okay, Nabil, very good. Sorry. So all of you, please note down this. Okay, and then raise your hand so that I can change the slide.
So is this the theorem?
Not theorem, we can say there's a theoretical part. Okay. All of you, please raise your hands once it is done. Okay, so now I think you understood that why LHD is equal to RHD, why the function is differentiable and LHD is equal to RHD. Okay. All of you, please raise your hands if it is done so that I can change the slide. Okay, Nabil. Okay, Noma.
1 minute, sir.
Okay. Okay, Atif.
Yes, done, sir.
Okay. Safa, Nabil Khan, is it done? Okay, Uzafa. Nabil Khan, is it done? Okay, great. So, okay, please note down this. And again, raise your hand. Okay. Okay, Atif. Okay, Nabil. Okay, Saif. Good. Okay, Noman. Huzaifa and Nabil Khan. Is it done? Huzaifa and Nabil Khan, is it done? Shall we start next? Okay, Huzaifa, good. Nabil Khan, is it done? Okay, great. Now, there are some points here. First thing I told you, when we will say that a function is differentiable at a point when there exists a unique tangent at that point. There exists only a single tangent at that point. Then we will say that the function is differentiable. Okay. Now, there are two cases when the function is not differentiable. First, if suppose this is point O, okay, we will say that the function is not differentiable if that point is a corner point. At this corner point, the function is not differentiable. Okay, you have already checked this function fx is equal to mod x. We have checked in the first question that this function is not differentiable at x is equal to 0. Why this do not differentiable at x is equal to 0? Because at x is equal to 0, we have a corner point. At corner point, a single tangent do not exist, two tangents exist. Okay, at this point, if you will draw a tangent, you will get this tangent and this one. So if you have a corner point, then there does not exist a unique tangent. That is why at a corner point, function is not differentiable. Okay, please remember one thing. When the function is not differentiable, either that point is a corner point, or second, or the function is not continuous at that point. For example, if we have this function, suppose this point is C. If the function is not different, is not continuous at that point, there is a break at that point, then also the function is not continuous. Sorry, the function is not differentiable. So we have a two condition when the function is not differentiable. First is if there is a corner point. Second, the function is not continuous at that point. Okay, one thing always remember, if a function is differentiable, then it will be continuous. Always remember, if a function is differentiable, then it will be continuous. But anyone can tell me if a function is continuous, then it will always be differentiable also. Is it correct or not?
Not always.
Not always. Because we can see here, this function is continuous at this point, but it is not differentiable because here we have a corner point. Okay, so let's discuss this point. First is if a function is differentiable at a point, it is continuous at that point, but the converse is not necessarily true. Why? Because suppose, for example, mod x, this function, this is the graph of modulus you have done in class 11th also, and we will do the graph in integration also. Okay. So we have this graph. At this point, the function is not differentiable because this is a corner point, but the function is continuous at this point. So if a function is differentiable, it will be continuous, but if it is continuous, it is not necessary, it is differentiable. Same example, mod x is continuous at x is equal to 0, but not differentiable at x is equal to 0. Okay, so I hope this point is clear to everyone. Now we will check the next point. If a function is discontinuous, it will not be differentiable at that point. This also we have discussed that if a function is discontinuous at any point, then it will not be differentiable at that point. Now, third point, LHD at any point P is equal to RHD at any point P, then fx is differentiable at point. We have already discussed in the previous slide. If LHD is equal to RHD, then it is differentiable, and it means there exists a unique tangent. I already told you that LHD is equal to RHD means there exists a unique tangent, and hence we will say that the function is differentiable. In other words, fx is differentiable at a point if the curve does not have P as a corner point. The same thing as per this graph. If you have a corner point, then the function is not differentiable. If you do not have the corner point, then it will be differentiable. If a function is not differentiable, what are the two conditions when the function is not differentiable? Then either the point is a corner point or it is discontinuous. Okay. Now, I hope all these 4 points are clear to everyone. Please note down these 4 points. Again, read these and let me know if you have doubt in any of these points. Okay. Please raise your hands once it is done.
Sir, corner point means it just passes through origin or it's like modulus.
Sorry, Nabil, will you please repeat?
So corner point means the graph will pass through the origin, or
No.
does it mean it's like modulus where it reflects back from the origin?
No, it doesn't mean that it passed through the origin. That means you have a corner in the graph. For example, your graph is coming like this and it now bend here. So this is the corner point. Okay, so at this point, your function will not be differentiable.
Yes,
Clear?
sir.
Okay.
So if the graph is bending anywhere, like
Yes.
sharp.
Sharp. Bend. Okay.
Yes, sir.
All of you, please raise your hands once it is done. Okay, Noma, very good.
Sir, modulus functions are differentiable.
Modulus functions are not differentiable at the corner points. Okay. For example, if this is a function that at this point, yes, it will be differentiable. But if we will talk about the corner point like this, then it will not be differentiable. But yes, they are continuous, not differentiable at the corner point. Okay, Nabil?
Yes, sir.
Okay, Nabil Khan, good. Atif, Huzaifa, Saf, please confirm if it is done. Atif, Huzaifa, and Saf, is it done? Shall we move to next?
No, sir.
Okay. Okay, Saf, then I will wait for you. Seth, is it done?
No, sir.
Okay.
Yes, sir. Done.
Okay, sir. Very good. Now next one. This is also homework. Okay. We need to complete this topic today. There's a very simple question. You need to find the relation between A and C and B and C if this is differentiable at x is equal to C. So it is nothing new. Just doing the same way as you have done the previous question, you will get your answer. Okay. In case you have any doubt, we can discuss this, but I'm sure you can solve this on your own. So all of you, please note down this. You have to complete this in homework and raise your hands once it is done.
Sir, can you show the fourth point of the last one?
Yes.
Done, sir.
Okay. So all of you, please note down this question, raise your hands. Then we will move to next. Okay, Nabil. Okay, Noma. Everyone, please raise your hands once it is done. Okay, Atif. So, Josefa, is it done? Josefa, is it done? Josefa, I'm going to start next question. Is it done? I need to solve this question. Josefa, you can solve it, okay? By the same method which you have applied in the previous question, try to solve this. Okay, just find the LHD and RHD. You will get your answer. Okay, please try this. In case you have any doubt, then we can discuss this in the next class. Okay, so Josefa, I'm going to check the next one. Okay, before that, okay, first, who can tell me? Anyone can tell me that what is the difference between this question and the previous questions which you have done so far? Anyone can tell me? Just leave this continuity, okay? Because this we don't need this. Suppose this is the question. Discuss the differentiability of this. So anyone can tell me what is the difference between this question and the previous questions which you have done? Is there any difference? Or the question
Here
is
we
same?
have to find with respect to 2 points, 1 and 2.
Nabil,
Usually we need only with one.
will you please repeat?
Usually we differentiate, we found the differentiability of a function with respect to only one term, like 1, 2. But
Okay.
here we have to find with respect to 1 and 2.
There is one more difference. That is partial correct. There's one more difference between this question and the previous one. Anyone else? Just check, compare the previous questions and this one. Discuss the differentiability of this. Anyone else can tell me. Atif, Josefa, Saif, Nabil Khan, Noma, and Nabil Ahmed. Please again compare this question with the previous questions. What's the difference? No one? Atif, Noma, Josefa, Saif, Nabil. What
X is
is
less than 1.
X is less than 1? That's fine, but there is some difference. Read the complete question. Discuss the differentiability of this function and read the any previous question. What is the difference?
Here we have to find for x between 1 and 2 also.
Yes, please check here. Noma, we need to check if fx is differentiable at a particular point. See, check the previous. Okay, for example, in this question, they are saying discuss the differentiability of fx at x is equal to 0. Here they have given us a single point and they are saying that discuss the differentiability at this point. But if we will check this question, then here they are saying discuss the differentiability of this function. Okay, here they have not given us a particular point. We need to discuss the differentiability of the function at all the points. They have not given a particular point here. Okay, in the previous questions, they have given us a particular point at which we need to check the differentiability. But here we need to check the differentiability at all the points. That is less than 1, greater than 2, or we can say simply x belongs to R. If you will analyze this, then this means x belongs to R. Complete number line is there here. Less than 1, between 1 and 2, greater than 2. So we need to check the differentiability at x belongs to R. Okay. The same thing which we have done in continuity. I hope everyone remember that topic. In continuity, first of all, we have checked the continuity at a single point. Then we have checked the continuity at complete real number for the complete real number. The same thing in the previous questions, we have checked the differentiability at a particular point. But here we are checking the differentiability for x belongs to R. That is for the complete real number line. Now, for that, we need some results. Okay, we will use these results directly in the question. First is every polynomial function is differentiable at each x belongs to R. Okay, so if you have a polynomial function in a question, then you can say that this is differentiable. Okay, we will use this result in the question. If we will get a polynomial function, then we will just write that this function is differentiable as this is a polynomial function. So remember, every polynomial function is differentiable. Now next is exponential function. Exponential function is also differentiable at x belongs to R. So in a question, if you are getting any exponential function, just write the standard statement. Third one, every constant function is differentiable at each x belongs to R. So if you have a constant function, then we will say that this is also differentiable at each x belongs to R. Same with the logarithmic function. Logarithmic function is differentiable at each points in its domain. Trigonometric and inverse trigonometric functions are also differentiable in their respective domain. Some difference product quotient of two differentiable function is differential. Okay, so please note down these results. We will use these results in the question directly. Okay, please note down this. Raise your hands once it is done. All of you, please raise your hands once it is done. Okay, Nabil. Everyone, okay, Atif. Okay, Nabil. Zephyr, Seth, Noma, please raise your hands if it is done. Okay, Noma. Zephyr and Seth, please raise your hands. Zephyr and Seth, is it done? Okay,
No,
sir.
sir.
Okay. Is it done, Seth?
1 minute.
Okay.
Yes, sir, done.
Okay, okay, good. Now, the next question. Discuss the differentiability of this function. Okay. So here we need to check this differentiability at each and every point. So we will do like this. For x is less than 1. Who can tell me this? Seth, can you tell me what is fx for x is less than 1?
1 minus x.
1 minus x. Very good. Which is a okay, fx is equal to 1 minus x. Polynomial, we will write the standard statement. This is a polynomial function. Polynomial function is differentiable, is differentiable, is differentiable everywhere, is differentiable everywhere. Hence, fx is differentiable, is differentiable for x is less than 1. Okay, so in the first part, it is 1 minus x, and we know that if x is less than 1, then we have this function, and this is a polynomial function. If you will check your standard results, then a polynomial function is everywhere differentiable. That's why we are saying that polynomial function is differentiable everywhere, hence fx is differentiable for x is less than 1. Now next value. Next is this value. So we will choose this one for x is greater than 1 and less than 2, fx is equal to 1 minus x into 2 minus x. Okay, please check here. I have not included 1 and 2. We're just taking the function between 1 and 2. So we have this fx is equal to this. Again, the same statement, polynomial function is differentiable, is differentiable everywhere, is differentiable everywhere. Hence fx is differentiable, is differentiable for x is greater than 1, less than 2. Now this third result, for x is greater than 2, fx is 3 minus x. Again, the same statement, polynomial function is differentiable everywhere, is differentiable everywhere. Hence fx is differentiable for x is greater than 2. Okay. Now, where there is a possibility that the function is not differentiable at this point, x is equal to 1, and at x is equal to 2. The same thing we have done in continuous function also. At these particular points, there is a possibility that the function is not differentiable. Why? Because when we will find the LHD, then we will choose this function for 1. When we will find RHD, we will choose this function. Then there is a chances that this function will become not differentiable for this point 1. Similarly, when you're finding the LHD for 2 and RHD, you have a different function. Hence, there are chances. So in these types of questions, please write the standard result for all these one when x is less than greater than. But for a particular point, there is a possibility that your function is not differentiable. Okay. Now, next we will check for x is equal to 1. Okay. Now we will check. Differentiability of fx at x is equal to 1 and 2. Okay, this you can do on your own. So please note down this. And after this, please start checking for 1 and 2 and share your answer. If anyone have a doubt, then please let All of you, please raise your hands once it is done so that I can change the slide. And then please try to check the differentiability at x is equal to 1 and 2. Good, Noma? So Noma, okay, Atif, Nabil, good. Now please try to check the differentiability at x is equal to 1 and 2. Okay, Nabil, very good. Please let me know if anyone get the answer. For x is equal to 1, this function is differentiable or not.
Sir, it is differentiable, sir.
Differentiable for x is equal to 1.
Yes, sir.
Okay, great. We'll now check for x is equal to 2.
Yes, sir, it is differentiable.
For 2 also, I think
Sir,
there.
because polynomial, right?
No, 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 no. You are not following this. Just give me a minute. Please check here. When you're checking LHD, then for left-hand derivative, you will use this function. Okay, and for RHD, you will choose this. Okay, Nabil. So there are the chances that for LHD and there are the chances that LHD and RHD will not be equal. Okay, so when you are finding the differentiability at a particular point, then you can't write the standard result. I will try to explain you by this graph. Okay, this is a graph of modulus function. This is 0. Okay, the same thing. Mod x is equal to x minus x greater than equal to 0 and less than 0. So this is what? This is x. This is what? This is minus x. This is fx is equal to x. This is fx is equal to minus x. This is point 0. So if we will check x is greater than 0, that means right side. So we have this function x, which is a polynomial function. So for greater than 0, we will say yes. For greater than 0, we will say yes, it is differentiable at all the points. But we are saying about the x is greater than 0. For x is less than 0, we have this minus x. Again, this is a polynomial. Yes, it is differentiable. Okay. But when we have to check that at 0, it is differentiable or not, then we will use the method of LHD and RHD. Now, if you will find the RHD, then you will get a 1. If you will find the LHD, this is minus 1. These two are not equal. Okay, because there's a corner point. So if you're finding that differentiability at a particular point, Nabil, then you can't use that standard result. Okay, you need to apply the same method which we have done in the earlier questions. Is it clear, Nabil?
Sir.
Okay, so x is equal to 1. Did you write the direct result?
Yes, sir.
No, that's not correct. Okay, please do in the same way as we have done the previous ones. Atif, Huzefa, Saif, Nabil Khan, and Noma, please let me know once it is done. Okay, or let me know if you have any doubt here. Okay, Atif, very good. Differentiable at x is equal to 1. Now check for x is equal to 2. No, Atif, that's not correct. Okay, please again check for x is equal to 2. This function is not differentiable at x is equal to 2. Okay. Again, please check your answer and correct it. Good, Noma, it is correct. It is differentiable at x is equal to 1. Good. All of you, please let me know if anyone have a doubt in this question. Okay, Atif. Please check for x is equal to 2. At x is equal to
Sir, x is equal to 2 is not
not,
differentiable.
not differentiable. Very good. So LHD at x is equal to 2. So it will be limit x tends to 2 minus fx minus f2 by x minus 2. Now for this 2 minus, which function we will choose, Atif? First, second, or third? Atif, Second one, good. 1 minus x into 2 minus x. 1 minus x, 2 minus x, minus f2. Okay, so put this value 2 in this function. So what you will get 1 minus 2, 2 minus 2 by x minus. Now this is equal to limit x tends to 2 minus 1 minus x, 2 minus x. Here you will get a 0 by x minus 2. Now put x is equal to 2 minus h. What you will get here, limit h tends to 0. In place of this x, we will write 2 minus h. In place of this x, we will write 2 minus h. In place of this x, please write 2 minus h minus. This is equal to, now limit h tends to 0. Open this bracket. So you will get what? 1 minus 2 plus h. And here you will get 2 minus 2 is 0 into h by minus h. Okay, so this h, this will cancel. Here you will get what? Negative limit. This negative in the denominator I have written here. Here you will get 1 minus 2 is minus 1 plus h. Put this limit, so minus 1. This will give you 1. So LHD is 1. Okay, and Arthur, what the RHD you are getting in this question? If you will check the RHD, then RHD will be minus 1. Okay, Atif, that's why this is not differentiable. Now we will find the RHD. RHD at x is equal to 2. So here we will get limit x tends to 2 plus fx minus f2 by x minus 2. This is equal to limit x tends to 2 plus, okay, fx. What is fx here? 3 minus x. 3 minus x minus f2 is 3 minus 2 by x minus 2. So here we will get limit x tends to 2 plus 3 minus x minus 1 by x minus 2. Put x is equal to 2 plus h. So this limit h tends to 0. 3 minus x, okay? 3 minus 2 plus h minus 1 by 2 plus h minus 2. Here we will get what? Limit h tends to 0. So here we will get 1 minus h minus 1 by h. So limit h tends to 0. Here you will get a minus h by h, which will give you limit h tends to 0 minus 1. So the final answer is minus 1. This is clear, Atif? LHD is not equal to RHD. So, but won't we take the second? No, we are finding the RHD, right hand derivative, 2 plus. 2 plus means we are approaching from the right side. Okay, 2 plus means we are approaching from the right side. So for that, we will choose the function 3 minus x. Okay, Atif, we are solving the limit. So we will apply the same concepts which we were using in continuity. The same thing. When you are finding the RHD limit 2 plus, that means you will approach from the right side. Is it clear, Atif? Okay, okay, very good. So all of you, please note down this. Let me know once it is completed. Okay, then we will end our class. So please raise your hands once all of you have, if all of you have done this, then we will end the class. Okay. Okay, Noma, very good. Nabil, Atif, Huzaifa, Saf, Nabil Khan. Please confirm if it is done.
Yes, sir.
Okay, Atif. Okay, Saf. Huzaifa, Nabil Khan, is it done? Huzaifa and Nabil Khan. Okay, Huzaifa, good. Nabil Khan, is it done? Okay, great. So this topic is completed. Now, please note down the, okay, I will erase this part. Please note down this. This is the homework. Discuss the differentiability. The same question you have done in continuity. Next in differentiability. You need to define the mod first. So please note down this. This you have to do in homework. If you have any doubt, we will discuss tomorrow. Okay, raise your hands once you will done this. Okay, Noma, very good. Okay, Atif, good. Rest of you, please confirm. Huzaifa, Saf, Nabil Khan. Okay, Nabil. Huzaifa and Saf, is it done? Huzaifa and Saf, is it done?
Yes, sir.
Okay, good. Huzaifa, is it done? Okay, great. This is the last question. Okay, this is a very, very, very important question. Okay, please note down this. Now, this chapter is completed, continuity and differentiability. Okay, and in group, we have shared one more assignment with you. So please, first of all, complete the questions which I have given from the slide. And after that, please complete the assignments. Okay, and please complete the questions of differentiation. Those are very, very important questions. So tomorrow we will start a new chapter, that is application of derivative. Okay. So raise your hands if you have noted down this question, then we will end our class. Okay. My number, okay. But I guess everyone have my number, so. Okay, I have again sent my number. So Noma, you can share the assignments on group also. Okay, because in your group there are only 2 students. So I do not face any difficulty in checking your homework. So if you wish, you can share the assignments on group. And rest of you, please complete the assignment and share with me. Okay, Nabil, okay, Nabil Khan. So whoever has completed this, okay. No. So whoever has completed this, then they can drop off. Okay, we will continue. We will start the new chapter tomorrow. Okay, then. Thank you.
Thank you, sir.
Okay, welcome. Okay, Zafar, you're welcome.